Welcome. In this video, we will explore indices, what they are, the key laws that govern them, and how to apply these rules in solving problems. Let's dive in. Let's assume we have this expression. Then A is called the base, and N can be called the power, exponent, or index. And this is what indices is all about. A number raising to a power. For example, if you have a raised to the power n, it means that a is multiplying itself by n times or n factors. Example, 2 raised to the power 3 means that 2 is multiplying itself 3 times. That is 2 times 2 times 2. And 3 raised to the power 5 means that 3 is multiplying itself 5 times. So we have 3 times 3 times 3 times 3 times 3. To understand indices very well, you have to understand the laws that govern indices. Law number 1, we have the multiplication law. Let's assume we have a exponent m multiplying a exponent n. Since the bases are the same, we maintain the base and add the exponents. This law holds only when you are multiplying two indices with the same base. If the bases are different, you cannot apply this rule. For example, we have 3 raised to the power 4 multiplying 3 raised to the power 5. The bases are the same, so we maintain the base and add the exponent 4 plus 5. And 4 plus 5 is equal to 9, so we have 3 raised to the power 9. Another example, we have 5 times 5 exponent 2. The bases are the same, we have 5 and 5, so we maintain the base. We add the exponents. Remember, there is 1 here, but it is not written. So we have 1 plus 2. 1 plus 2 is 3, so we have 5 raised to the power 3. And 5 exponent 3 will give us 125. Another example. Let's say we have 3x exponent 4 times y exponent negative 2 multiplying 4x exponent 2 times y exponent 3. We first of all multiply the numbers. 3 times 4 is 12. And we move to the next variable, that is x. X exponent 4 times x exponent 2. The bases are the same, so we maintain the base x and add the exponents 4 plus 2. Then we move to the next variable, which is y. We have y exponent negative 2 multiplying y exponent 3. The bases are the same, so we maintain y and add the exponents negative 2 plus 3. So we have 12 here, and 4 plus 2 is 6, so we have x exponent 6. Negative 2 plus 3 is 1, so we have y exponent 1, which can be written as y. The next law, we have the division law, also same base. Let's assume we have a exponent m divided by a exponent n. Since the bases are the same and they are dividing, we maintain the base and subtract the second exponent from the first exponent. So we have a exponent m minus n. This can also be written as a exponent m divided by a exponent n, and the law still holds. We subtract the second exponent from the first exponent and maintain the base. This law is known as the division law of indices with the same base. For example, if we have 3 exponent 4 divided by 3 exponent 2, since the bases are the same and they are dividing, we maintain the base and subtract the second exponent from the first exponent. So we have 3 exponent 4 minus 2, and 4 minus 2 is 2. So we have 3 exponent 2, and 3 exponent 2 means 3 multiplying itself twice. So 3 times 3 is 9. Another example, we have x exponent 7 divided by x exponent 3. Since the bases are the same and they are dividing, we maintain the base, which is x, and subtract the second exponent from the first exponent. So we have x exponent 7 minus 3, and 7 minus 3 is 4. So we have x exponent 4. The next law, we have the power of power law. Let's assume we have a exponent m in a bracket and another exponent outside the bracket. If you have an exponent and another exponent, then it means that we maintain the base and multiply the two exponents. So we have a exponent m times n. Example, if you have 3 exponent 2 with another exponent of 3 outside the bracket, then it means we'll maintain the base, which is 3, and multiply the two exponents, that is 2 times 3. So we have 3 exponent 6. Aside the 3 popular laws of indices, there are other rules of indices that can also help us to understand indices very well. Remember, rules and laws can be used interchangeably, so the rules can also be called laws. For the first one, we have the zero exponent rule, which states that any non-zero number raised to the power 0 is equal to 1. That is, if you have a number exponent 0 and that number is not 0, then the answer is equal to 1. If the base a is also 0, then 0 exponent 0 is undefined. So the base should not be equal to 0 for this law to hold. And this is the zero exponent rule. Any non-zero number raised to the power 0 is equal to 1. The next rule, we have the power of a product rule. Let's assume we have a times b, all exponent n. And since a and b are all in the bracket and they are all having an exponent of n, then it means the exponent of n will affect a and will also affect b. So we have a exponent n times b exponent n, and that is the power of a product rule. For example, if you have 2 times 3 all raised to the power 2, then it means that the exponent, which is 2, will affect each of the numbers in the bracket. So we have 2 exponent 2 times 3 exponent 2. And 2 exponent 2 means that 2 is multiplying itself twice. That is 2 times 2, and is 4. 3 exponent 2 means 3 is multiplying itself twice. That is 3 times 3, and is 9. 4 times 9 is 36, and that is the answer. Let's take another example. We have 3x exponent 2 times y exponent 6 all raised to the power 2. It means that this exponent is going to affect each variable or number in the bracket. So we start with 3. If no exponent is written, then it means 3 is having an exponent of 1. So we are going to multiply 2 by the exponent over here. That will be 2 times 1. So we have 3 exponent 2. The next one, we have x exponent 2. And so this exponent will multiply the exponent outside the bracket, and it will give us 4. So we have x exponent 4 here. Then we move to y. Y is having an exponent of 6, and there is another exponent of 2. So we multiply 6 by 2, and y will have an exponent of 12. And we can go ahead and simplify 3 exponent 2. That means 3 is multiplying itself twice. That's 3 times 3, and it's 9. We have x exponent 4 and y exponent 12. The next rule, we have the negative exponent rule. If you have a exponent, a negative number, then this can be written as 1 over a exponent, the number without the negative sign. And this is the negative exponent rule. For example, if you have 3 exponent negative 1, then it can be written as 1 over 3 exponents, the number without a negative sign. And 3 exponent 1 is 3, so we have 1 divided by 3 as the answer. Another example, we have 2 exponent negative 3, and it can be written as 1 over 2 exponent 3. That is, you take the negative sign off, and 2 exponent 3 means 2 multiplying itself 3 times. So we have 2 times 2 times 2, and it's 8. So we have 1 divided by 8. The next one, we have power of a quotient rule. Let's assume we have a divided by b all raised to the power n. Since a and b are all in the bracket, then this exponent is going to affect each of them. So we have a exponent n divided by b exponent n. But the denominator b should not be equal to 0, or else it will be undefined. A function is undefined when the denominator is 0. So this is the power of a quotient rule. Example, we have 2 divided by 3 all exponent 3. So the exponent is going to affect the numerator and also affect the denominator. So we have 2 exponent 3 divided by 3 exponent 3. And 2 exponent 3 means 2 is multiplying itself by 3 factors. That is 2 times 2 times 2, and it's 8. And also 3 exponent 3 means 3 times 3 times 3, which is 27. So we have 8 divided by 27. Rule 5. Rule number 5 is a combination of the negative exponent and power of a quotient rule. Let's assume we have a divided by b with a negative exponent. Then the first thing to do is to find the reciprocal of a and b, that is b over a, and the exponent becomes positive. And this becomes the power of a quotient rule. So the exponent will affect b and also affect a. We have b exponent n divided by a exponent n. But this law holds if a is not equal to 0 and b is also not equal to 0. Because if a is 0, it will make these functions undefined, and also if b is equal to 0, this expression here will be undefined. Example, we have 3 divided by 2, all exponent negative 2. So first of all, we find a reciprocal of 3 over 2, and we have 2 divided by 3, and the exponent becomes positive. And now the exponent will affect each of the numbers in the bracket. So we have 2 exponent 2 divided by 3 exponent 2. 2 squared is 4, and 3 exponent 2 is 9. So we have 4 divided by 9. The next we have the fractional exponent rule. If you have a exponent m over n, that is a number with a fractional exponent, then we can open a root in a bracket, put the base a under the root, and the denominator of the exponent comes here, that is the nth root of a, and the numerator of the exponent comes here as an exponent. So we have nth root of the base a, and the numerator m is an exponent to the whole expression. This is the fractional exponent rule. Examples: if you have 81 exponent 1 over 2, then we can open the root sign, put the base, which is 81, under the root, and the denominator 2 comes here as a square root, but for square root we don't normally put the 2 here, and the numerator of the exponent 1 comes here as an exponent, but we can choose not to write it. So any number exponent have can be written as the square root of that number, and the square root of 81 means what number can multiply itself twice to give you 81, and we have 9 as the answer. The next example, we have 125 raised to the power 1 divided by 3. So according to the rule, we open the root sign, put the base 125 under the root, and for the fractional exponents, the denominator, we can put it here. Aside square root, any other number can be put here, and the numerator of the fractional exponent, which is 1, comes here. But as for 1, we can choose not to write it, and the answer will still be the same. The cube root of 125 means what number will multiply itself 3 times to give us 125? And it's 5. We have an exponent here, 1. 5 exponent 1 is still 5. So any number exponent 1 over 3 can be written as the cube root of that number. The next one, we have 8 exponent 2 divided by 3. So according to the rule, we open the root, put the base, which is 8, under the root, and the denominator of the fractional exponent comes here, and the numerator of the exponent 2 comes here. And the cube root of 8 means what number will multiply itself 3 times to give us 8, and it's 2. But remember, we have an exponent of 2 here. 2 raised to the power 2 means 2 is multiplying itself twice. 2 times 2 is 4. Now, we are going to apply the rules of indices to solve some examples. Example 1. Without using mathematical tables, simplify 16 over 81 exponent negative 3 over 4. We have 16 over 81 all exponent negative 3 over 4. According to the negative exponent rule, we can find the reciprocal of 16 over 81, and the negative sign will vanish from the exponent. So we have 81 over 16 exponent positive 3 over 4. Now let's apply the power of a quotient rule. That means the exponent, which is 3 over 4, is going to affect each number in the bracket. So we have 81 exponent 3 over 4 divided by 16 exponent 3 over 4. And we apply the fractional exponent rule. That means we open a root sign for 81, put the denominator of the exponent here, and the numerator of the exponent becomes an exponent. And we do the same thing for 16. Fourth root of 16 cube. Now the fourth root of 81 means what number can multiply itself 4 times to give us 81? You can also use the calculator to get the answer, and it's 3. We have an exponent of 3 here. And the fourth root of 16 is 2. Exponent 3. 3 cubed is 27. And 2 exponent 3 is 8. This is the answer. From this part, you can also write 81 as 3 exponent 4. And the exponent is 3 over 4. 16 can also be written as 2 exponent 4. And there is an exponent of 3 over 4. You can cancel out 4 and still have your 3 exponent 3 and 2 exponent 3. This is another method. Example 2. Without using mathematical tables, simplify 16 exponent negative 3 over 2. We have 16 exponent negative 3 over 2. And according to the negative exponent rule, this can be written as 1 over 16, and the negative will vanish. So we have positive exponent here. Then we apply power of a quotient rule where the exponents affect each number in the bracket. So we have 1 exponent 3 over 2 over 16 exponent 3 over 2. 1 exponent 3 over 2 is 1. You can also apply the fractional exponents rule on it and you still get 1. And applying the fractional exponent rule for 16 exponent 3 over 2, we open a square root for 16 and put the numerator of the exponent, which is 3, over here. So we have 1 over square root of 16 is 4. We have an exponent of 3. And 4 multiplying itself 3 times will give us 64. This is the answer. Example 3. Without using mathematical tables, simplify 64 over 25 exponent negative 1 over 2. We apply the negative exponent rule. So we find the reciprocal of 64 over 25. And we have 25 over 64. And the exponent becomes positive. We then apply the power of a quotient rule where the exponent affects each number in the bracket. So we have 25 exponent half over 64 exponent half. We then apply the fractional exponent rule. Any number exponent half can be written as the square root of that number. So we have square root of 25 over square root of 64. Square root of 25 is 5 and the square root of 64 is 8. Example 4. If 2 exponent negative n is equal to x, find x. We have 2 exponent negative n is equal to x. 2 exponent negative n can be written as 2 exponent negative n over 1. And according to the negative exponent rule, we can find a reciprocal, that is 1 over 2 exponents n. That is, the negative will vanish from the exponent when we take the reciprocal. And this is equal to x. Let's cross multiply. We have 2 exponent n times x is equal to 1. That is, x will multiply 2 exponent n, and 1 will multiply the denominator over here, which is over 1. Since we are looking for x, we divide through by 2 exponent n. So we have 2 exponent n times x over 2 exponent n is equal to 1 over 2 exponent n. And 2 exponent n will cancel out. And we have our x to be equal to 1 over 2 exponent n. And that is x. Example 5. If 5 exponent n is equal to k, find 5 exponent n plus 1. 5 exponent n is equal to k. Let's multiply each side of the equation by 5. So we have 5 exponent n times 5 is equal to k times 5. And 5 can be written as 5 exponent 1. And according to the multiplication law or rule of indices with the same base, when the bases are the same, we maintain the base and add the exponents. So we have n plus 1. 5 times k is 5k. And this is the answer. 5 exponent n plus 1 is 5k. Example 6. Simplify 27 times 3 exponent negative 2 in one bracket times in another bracket 8 times 2 exponent negative 3. Let's change 27 to 3 exponent 3. We want to have the same base. So we have 3 exponent 3 times 3 exponent negative 2. Since 3 exponent 3 is 27, and that will help us get the same base. And we change 8 to 2 exponent 3 to match the base of 2 here. So we have times 2 exponent negative 3. And according to the multiplication law of indices, when the bases are the same, we add the exponents. So we have 3 exponents, we have 3 here, plus negative 2. When the plus sign meets the negative sign, we maintain the negative sign. In another bracket, we have 2 here. We add the exponent, that is 3 plus negative 3. When you have plus and minus, it can be written as minus. We have 3 exponent 1 here, and here we have 2 exponent 0. And 3 exponent 1 is 3. 2 exponent 0 is 1. And 3 times 1 is 3. That is our final answer. Example 7. Simplify 7 exponent 6 times 7 exponent negative 3, all divided by 7 exponent 4. We have 7 exponent 6 times 7 exponent negative 3 all over 7 exponent 4. At the numerator, the bases are the same, so we add the exponents. The bases are the same and they are multiplying, so we add the exponents. So we have 6 plus negative 3, and it can be written as 6 minus 3 divided by 7 exponent 4. And 6 minus 3 is 3, so we have 7 exponent 3. And here, since the bases are the same and they are dividing, we subtract the second exponent from the first one. So we have 7 exponent, 3 minus 4. And 3 minus 4 is negative 1. And according to the negative exponent rule, this can be written as 1 over 7 exponent 1. But 7 exponent 1 is 7. And this is the final answer. Example 8. Simplify 256 exponent negative 1 over 4 times into bracket 225 exponent 1 over 2 plus 58 exponent 0. We have 256 exponent negative 1 over 4 times 225 exponent 1 over 2 plus 58 exponent 0. 256 exponent negative 1 over 4 can be written as 1 over 256 exponent positive 1 over 4. And any number exponent half can be written as the square root of that number. And any non-zero number exponent 0 is 1. And this can be written as 1 exponent 1 over 4 over 256 exponent 1 over 4. The square root of 225 is 15. And 1 exponent 1 over 4 is 1. So we have 1 over 256 exponent 1 over 4 can be written as, according to the fractional exponent rule, we open a root for 256, put the denominator of the exponent 4 here, and the numerator of the exponent becomes the overall exponent here. And 15 plus 1 is 16. So we have 1 over the fourth root of 256. It means what number can multiply itself 4 times to give you 256, and it's 4. We have an exponent of 1 here, and 4 exponent 1 is still 4. 16 divided by 4 is 4, and that is our final answer.